Welcome back. It is officially day 3 of Unit 1, still talking about scientific inquiry. Make sure that you guys have your notes out and ready to go, and you're following along with me as we complete this video. All right, so today's aim, what is the importance of the scientific inquiry method? Well, the first thing we can annotate in this aim is the word inquiry. Okay, we went over this when we talked about our day 1 practice. But the word inquiry is talking about asking questions. Okay, and along with those questions, when we complete the scientific method, we're also looking for answers. So we're asking questions and finding answers. Right, and those two processes together make up the scientific method. So we're asking questions and finding the answers to those questions. All right, next up we've got our do now. Which statement best describes a hypothesis? A hypothesis is a process of making careful observations. B, the conclusion drawn from the results of an experiment is part of a hypothesis. C, a hypothesis serves as a basis for determining what data to collect when designing an experiment. Or D, the facts collected from an experiment are written in the form of a hypothesis. So right now, press pause on this video. Answer this question on your own, and then press play when you're ready to go over it. All right, so before we answer this question, let's write down what do we know about hypotheses? Well, we know that we're going to call them an educated guess about what's going to happen in your experiment. And because of that, we know that they're written before we perform the experiment. And finally, the last thing we know is that they're written as a statement, not a question. So let's use those 3 things to answer this question, okay? Letter A says a hypothesis is a process of making careful observations. Well, correct me if I'm wrong, but don't we take observations while we perform the experiment? And we have to write the hypothesis before the experiment. So that can't be right. We're going to cross that one out. B, the conclusion drawn from the results of an experiment is part of a hypothesis. Well, once again, we're writing our hypothesis before we start the experiment. So can we go ahead and include the conclusion in that hypothesis? No. All right, C, the hypothesis serves as a basis for determining what data to collect when designing an experiment. Well, I don't see anything wrong with this yet because we know that we write the hypothesis before the experiment, so that can give us information about determining what data to collect. But I'm going to put a maybe there, and we'll come back to it. All right, and finally, answer D. The facts collected from an experiment are written in the form of a hypothesis. Well, once again, we have to write the hypothesis before we perform the experiment, and this is saying the facts collected from the experiment. So we can't include those in our in our hypothesis if it hasn't happened yet. Cross that one out as well. So the correct answer here is going to be C. A hypothesis serves as a basis for determining what data to collect when designing an experiment. All right. So today's aim is deciding what is the importance of the scientific method. But in order to do that, I want us to spend some more time going over the vocabulary associated with experiments and how to set those up. So before we get started today, I want us to review the vocabulary we learned yesterday. First up, we've got hypothesis, all right? What is a hypothesis? Well, we know that it's an educated guess, right? But I want you guys to write down that it is the statement that is crafted before an experiment to predict what will happen in the experiment. Right? So this is a statement you are crafting where you predict what will happen in that experiment. All right, what is the dependent variable? Well, the dependent variable is the variable or I'll say, this is what you are measuring in an experiment. So keyword is measuring for dependent. Independent variable is going to be what you are manipulating. Ooh, my handwriting, yikes. What you are manipulating or changing in an experiment. So the keyword there is manipulating. All right, then we've got experimental group and control group. So we talked about this yesterday, but the experimental group is the group that receives the independent variable treatment. And the control group is the group that does not receive the IV treatment. All right, so keep each of these vocabulary words in your mind as we go through today's lesson. They're going to be very, very important when we're talking about experiments. All right, so we have got 3 practice problems that we're going to do today, and they all revolve around the Simpsons. Okay, so I'm going to read each of these passages, then we're going to answer the questions together. First up, Homer notices that his shower is covered in a strange green slime. His friend Barney tells him that coconut juice will get rid of the green slime. Homer decides to check this out by spraying half of the shower with coconut juice. He sprays the other half of the shower with water. After 3 days of treatment, there is no change in the appearance of the green slime on either side of the shower. So in this passage, what was the initial observation? Well, we read right here that his initial observation is that his shower is covered in a green slime. All right. So next up, we're told to identify the hypothesis. So what is Homer's hypothesis? Well, his friend Barney said that coconut juice will get rid of the green slime. So his hypothesis is going to be, if a shower is sprayed with coconut juice, then the green slime will disappear. So what is our control group here? Well, remember, control group does not receive the independent variable treatment. So the control group here is going to be the shower that does not receive that coconut juice, or the shower that half of the shower that is sprayed with water. All right, next up, we've got the independent variable. Remember, this is the one that is manipulated or changed. So the variable that's being changed here is the coconut juice. Okay, dependent variable is what's being measured or what is responding to the treatment. So I'm going to put also measured here, because what are we measuring? We're measuring the amount of slime in the shower. Okay. Now, yesterday, I also told you there's a trick to setting up your hypothesis. If you set it up correctly, it should read something like this. If IV, then DV. So let's double check and make sure I did this correct. Well, my hypothesis is if a shower is sprayed with coconut juice, there's my IV, then the green slime will disappear. So green slime is going to be my dependent variable. All right, 2 more questions. Number 6, what should Homer's conclusion be? Well, it says that after 3 days of treatment, there is no change in the appearance of the green slime on either side of the shower. So unfortunately, it didn't work. So his conclusion should be spraying coconut juice in the shower does not remove green slime. All right, and finally, number 7, how can this experiment be improved? This also brings in the concept of scientific validity that we mentioned yesterday. Remember, if an experiment is valid, it's true, it's right, it's real. So there are 2 ways we can improve validity. And these 2 ways are going to come up a lot, so make sure you guys write this down. So 2 ways we can improve validity are, 1, you can increase the sample size. So in this case, we would we would use more showers. So increase the sample size, also put more showers. Usually we would be talking about test subjects, but in this case, they're not people, they're showers. The second way we can improve validity is to repeat the experiment. You might also say increase trials. So he could do this more times to see if he can improve that experiment and its results. All right, so 2 ways to improve validity: increase sample size and increase trials. He only did this once, so he would probably want to do it more times to make it more valid. All right, there is all of your answers for question 1. I did not give myself enough space to write on here, so if you're confused about what I'm saying or any questions about this material, please write that down as always, and I will get back to you, okay? Moving on to number 2. Krusty was told that a certain itching powder was the newest best thing on the market. It even claims to cause 50% longer lasting itches. Interested in this product, he buys the itching powder and compares it to his usual product. One test subject, A, is sprinkled with the original itching powder, and another test subject, B, was sprinkled with the experimental itching powder. Subject A reporting having itches for 30 minutes. Subject B reported to have itches for 45 minutes. So in this example, let's identify the hypothesis. Well, Krusty was told that this new itching powder causes 50% longer lasting itches. Oh wait, I need to, let me write this as a hypothesis. So if a subject is sprinkled with the new itching powder, then they will have 50% longer lasting itches. All right, so there's our hypothesis. What is our control group in this experiment? Remember, control group does not receive the independent variable. So in this example, our control group is going to be test subject A that is sprinkled with the original itching powder. All right, what is our independent variable? Well, let's check out our hypothesis. If the subject is sprinkled with the new itching powder, that's our IV, okay, so then same thing for our DV. Let's check out our hypothesis. 50% longer lasting itches. So our DV is going to be length of itches, because that's what we are measuring. We're measuring how long that test subject itches for. All right, number 5, explain whether the data supports the advertisement's claim about its product. Well, looking at our data, we see that subject A reported having itches for 30 minutes and subject B had itches for 45. The original hypothesis was that they would have itches for 50% longer lasting itches. So using this data, we can see that it's correct, okay? The new itching powder, let me rewrite this, okay? So yes, the data does support the advertisement's claim. Subject B had 50% longer lasting itches than subject A. All right, and finally, how can this experiment be improved? Remember, we're talking about increasing validity. So two things we can do are we can increase the sample size or use more test subjects. And we can also increase the trials. So repeat the experiment. All right, now I know we have one more problem. I actually want you guys to try this one on your own. So use my two guides as a model to answer this third practice problem. If you have any trouble with it, you know how to find me. Send me a message on Remind, shoot me an email, and I will help you work this one out, okay? As soon as you have completed that problem, I want you to work on this exit ticket. This is how I'm going to know that you have completed and understand today's work, all right? Once you're done, submit this worksheet on Google Classroom and let me know if you guys need anything else. I hope you have a wonderful day and I will see you tomorrow.